Hi guys, good morning. So this video we focus on branch group instructions. Okay. So what is branch group instruction? So the branch group instruction is just alter the sequence of program flow. Okay. Just skipping the sequence of program flow. So that's called as branch group instruction. So this branch group instruction is classified into two types. So one is a conditional branch group and another one is unconditional branch group. These are the two types of branch group instruction. One is the conditional and another one is the unconditional. Okay. So conditional means check the status of flag register. Based on that the program sequence will scale. In unconditional branch group instruction means without checking any condition, whatever address location specified in the instruction, that location is passed to the program counter. Okay. So that's a unconditional branch group instruction. The first one is conditional. So in this conditional branch group instruction, check the status of flag register. Okay. So in this flag register, we have the 5 status already see in the video. Okay. In the flag register, you can check carry, 0 and sign, then parity. Okay. So carry, then 0, sign, parity, odd parity or even parity, plus or minus, 0 or non-zero, carry or no carry. Okay. Just to check the 4 conditions. This condition is true, the specified location is moved to the program counter. Suppose this condition is false, just ignore the instruction. The next executing instruction directly execute. It continue the program flow. Okay. Here they are using 4 instructions: jump, call, return, restart. Okay. So these 4 instructions comes under conditional and unconditional. Okay. So both the functions, conditional function and also unconditional, these 4 instructions are involved. Okay. That will see one by one. Okay. The first function is jump. Okay. The response of jump function in conditional group and also unconditional group. Now we will check. First, we check in conditional group. Okay. So in this conditional group, check the condition. Whether the condition is true, it will go to the specified location is go to the program counter. Okay. This instruction you can write, okay, JMP for jump. So this instruction you can rewrite JNC, JC, JNZ, JZ, JP, JM, JO, JE. Okay. So this jump instruction you can write in conditional group instruction JNC. So JNC for jump on no carry, JC for jump carry. If carry present, you can go the corresponding location. JN is a jump on non-zero, J is a jump on 0, JP jump on positive value, JM jump on minus negative value, JO jump on odd parity, jump on even parity. Okay. Just to check the status, whether the status is true, it go to the location. So whatever location you specify in the instruction, that location is passed to the program counter. Okay. So now we will check. Consider one example, add B. Okay. So add the 2 register content A and B. So next instruction JNC 4300H. Okay. So the program counter value 4100 8 point, add B 4101 8 point, JNC 4300H. Before execution of this instruction, the program counter PCL and PCH the lower address and higher address. Before execution of this instruction, the program counter higher address is 41, lower address is 01. Okay, before execution. So after execution of this instruction, just check the condition. So jump on no carry. So after addition of these two register, the result is produced carry or no carry. Okay, suppose the result is not producing a carry, this condition is true. Okay, so once the condition is true, whatever address specified in the instruction, that specified address location is passed to the program counter. So after execution of this instruction, the higher order address is 43, lower order address value is 00. Okay, so whatever instruction, in that instruction, the specified location 4300, this value is passed to the program counter. Okay, likewise you can check all the instructions. Okay, so one more example, add B J Z 4350. Okay, so you consider one more example, add B J Z 4350. Okay, so here also you are adding the two register content A and B. Okay, so after execution, the result of the accumulator is 0 value or non-zero value. So all the values are 0 or non-zero value. Just you check the condition. Okay, suppose the result is 0. So in this case, the instruction is true. Okay, so once this instruction is true, the specified location 4350 is moved to the program counter. So PC. Okay, so PC, H and PCL. So before execution 4300 4299. So this is the address of these two instruction. Okay, so before execution, the program counter higher value 43, lower value 00. So after execution of this instruction, the condition is true, the specified address location is transferred to the program counter. So after execution, so this value is placed to the program counter. Okay, so it's a conditional group. The response of unconditional group. The same instruction execute in unconditional group. The instruction rewrite JMP 4300, the program counter value 4100. So it's PC. Before execution, the program counter value is 4100. So in this memory location, it point the instruction jump 4300. Okay, so in this instruction, without checking any condition. Okay, so we don't bother about the carry and parity and zero values. Okay, so just this execute the locations. So once this instruction is present, after execution of this instruction, the specified memory location 4300 is transferred to program counter. Okay, so it's a program counter register location. PCH is a higher order address, PCL is a lower order address. Before execution, the memory location is 4100. After execution, the specified memory location 4300, this location is transferred to the program counter 4300. So next instruction, call instruction. Okay, the function of call instruction in conditional group and also unconditional group. Okay, so it's checked one by one. So in the conditional group, here also you can check the status of the flag register. Okay, here also check the 8 status. So call on no carry, carry, non-zero, 0, positive value, minus value on odd parity or even parity. Okay, so in odd parity means all numbers of ones and zeros present in the result. Even parity means even number of ones and zeros present in the result. Okay, so CP means it's a positive value, CM means negative value. Okay, so based on this condition, the instruction is working. Okay, so whether the condition is true, it will go to the specified memory location. Suppose the condition is false, just ignore the instruction and execute the next sequence of the instruction. For example, here I am writing one program. So in the PC for program counter, the 4100, it's a memory location of the corresponding instruction. The 4100, it point CNC 4250. So CNC for call on no carry. Okay. So if no carry, call the new memory location. Okay. The condition is true. The specified memory location is 4250. This 4250 location is transferred to PC and execute the corresponding instruction. So after finish the call function, it come back to the main program. Okay. So before come back to the main program, first the next executing location 4103. So this location is stored to the stack pointer. Okay. So this location is stored to the stack pointer. After that, the new location 4250 is moved to program counter. Okay. So it's a structure of a stack pointer. Stack pointer always point the top of the stack. Okay. This SP represent for stack pointer. So SP minus 1, the top of the stack here, it point here. The SP minus 1, it reduced by 1. So in this location, you can store the next executing location 4103. So in this location, the higher order address location 41. So this value is stored here. Then you decrement the stack pointer value SP minus 2. So in this location, the lower order address of the next executing location 03. So this value is stored here. Okay. Then now the stack pointer is point SP minus 2. So this value. So current location of the stack pointer. Then the program counter new value. So the new value is 4250. Okay. So this 50 is a lower order address location. 42 is a higher order address location. Here you can place. Okay. So whatever instruction here, that instruction you can fetch and execute. Okay. The same instruction performing in unconditional group. So in this unconditional group, you can write the program. So program counter value 4250. Before execution 4250. It point on mnemonics. So call 4350. So in this instruction, we don't check any status. Okay, so without checking any status, the specified memory location is moved to the program counter. Okay, so here also you first check the next executing address location. So 4253. So this is a next executing memory location. So in this location, you can write one instruction. So A comma C. Okay, so after call program, so it finished. Once the call function is finished, again come back to the main program. Okay, so this memory location is stored to the stack pointer. Okay, so 4253. So 53 is a lower order address, 42 is a higher order address. First you load the higher order address here 42 and lower order address is 53. Now the stack pointer is pointing in SP minus 2. Okay, the new value of the program counter you can get from here. Okay, the higher order address location is 43. Lower order address location is 50. So the next instruction is return. So return to the main program. So I'll go to the subprogram, again come back to the main program. The final instruction is return. Okay. So in this instruction also you can check the condition. Okay. So or and C. So return on no carry. If no carry is present in the result, again return to the main program. So likewise you can check the condition. So or and Z. Return on non-zero or O. So return odd parity, return positive value. Okay. Likewise, you can check the conditions. Okay. So here we are following the 3 steps. Okay. So it's a stack pointer. So top of the stack, mention the program counter lower value. Once increment the stack pointer value, so that location is point the program counter higher value. Okay. So here we can use return. Okay, so after return instruction, the program counter, it load the new address location. So this address location is get from the stack pointer. So stack pointer is store the 16-bit data and also 16-bit address. Okay, so while the microprocessor come back to the main program. So in this case, the stack pointer is stored in the 16-bit address location. The next executing instruction of the main program, that location is stored to the stack pointer. Okay, the program counter first one, the stack pointer is pointing the program counter lower order address. I consider here the program counter value in stack pointer is 4350. Okay, so in this 4350, this 50 is a lower order address location. So this location is stored in the stack pointer. The 43 is a higher order address location. So this location is stored to the SP plus 1. Okay, now you get the lower order address and also higher order address from the stack pointer. So here you can get the first lower order address 50 and then the higher order address is 43. So it's a current execution instruction location for the main program. Okay, so in this location whatever instruction is placed, that instruction you can fetch and execute. Okay, the next one is unconditional group. So unconditional group, the same return instruction without checking any condition, it come back to the main program. Okay, the stack pointer, so this location is stored 45, SP plus 1 store 50. Okay, so this 45 is a program counter lower order address, this 50 is a program counter higher order address. So after executing this return instruction, the program counter new address location is 50, 45. So in this location, so whatever instruction is present, that instruction will fetch and execute. The next instruction is restart. Okay, so this instruction is a one kind of software interrupt. Okay, so this instruction you can mention in different software interrupts, RST 0, 1, 2, 3, 4, 5, 6, 7. So up to 8. So 8 varieties of restart instruction here we are using. Okay, so it's a simple program of restart instruction. So the program counter value, so first instruction 4500. So in this memory location it specify RST 1. Okay, so this RST 1 is a one kind of software interrupt. So it's a vector interrupt. Whatever memory location specified here, so in this location is transferred to the program counter. Okay, the 4501 is the next executing location. Okay, so after execution of this restart instruction, okay, after finishing the restart function, again it come back to the next instruction 4501. So in this memory location you point move A comma B. So next to 4502 move C comma D. Okay, so it's a simple program. So once rise the command OST1, so the microprocessor stop the current program. So it will go to the specified location of this function. Okay, so RST1. So this location is moved to the program counter. So before moving this location to program counter, whatever value present in the program counter, this value is moved to the stack pointer. Okay, so it's a 16-bit address. The lower order address is 01, higher order address is 45. Okay, so first you can move the next executing location of the main program, the higher order address 45. So this 45 is moved to stack pointer. So stack pointer -1. So in this location you can move the higher order address location. So PCH, program counter higher value. Okay, then you can move the lower order address 01. So this value is moved to SP -1. Okay, so 01. Now the current point in the stack pointer is SP -2. Okay, so it's a program counter new value. So what is the value update in here? The specified location of the program counter. So the specified location of the RST1. So this value is moved to the program counter. For example, I am considering the vector value is 4500. Okay, sorry, 4565. So it's a vector location of this instruction. This is an example value I consider. Okay, so it's a lower order address, it's a higher order address. So this value is passed to the program counter. Okay, so after execution of this instruction, the new value stored in the program counter 4565. Okay, so far we discussed the branch group instruction. Next session we focus on machine control group instruction. Okay, so thanks for watching my video. Please subscribe. Thank you.